Everything that the community comes up with, don't go for it because it doesn't. A lot of the things are just meaningless. Now there's one more program here, and that's called Monkeys. Let me see if I can find it here. Monkeys, there it is. And because here's the problem. What I was doing before, you may not have been impressed by it, even though it was so impossible to find these different this one target phrase. That's a single monkey. How many stars are there in our galaxy? Did anybody know? It's about 10 to 100 billion. There's a lot of stars, and probably many of those have planets floating around them, orbiting around them. How many galaxies are there in the universe? There's about 100 billion of those. So you've got 10,000 billion stars. Certainly one of them would be able to have this life because we have so many possibilities of producing it. Well, this program puts the lie to that because what I'm doing here is I'm going to give them unbelievable number of monkeys, unbelievable speed that they're typing, and unbelievable length of time, and you'll see that you just don't get any good information. So here's for instance, if I were typing out 4 characters per second, this program is trying to print out tomorrow and tomorrow and tomorrow, creeps in its petty pace from day to day, to the last syllable of recorded time. Out! Anyhow, I won't go on from there. But anyhow, that's what it's trying to produce. Okay, and you can see that it's easy to do it. Just 4 characters a second. We could print out Homer or Shakespeare's sonnet real easily. But let's let a monkey go at it here. And we'll start out doing 1 monkey, 1 key per second, and at real time, 1 second per second. And I begin it, and it's the same output that we got out of the other monkey program, but this is done by simulation rather than by actually running it. It's just saying if you were to go for 10 seconds, you see I got 2 numbers there. The second line is seconds. That's seconds that are gone by, and the upper line is characters. You almost print out a character. When it gets to 30, you'll print out your first character. Okay, and that's about what the other one did. Remember, it took about 30 characters to get it. So here we go: 27, 28, 29, 30, and then the top one goes to 1 character. We just typed the T in tomorrow. Okay. Now, if we were to sit here for another 30 times as long, about 1,000 seconds, we would type out T-O. And if we were to go 30 times that, we would get T-O-M. And if we stay overnight, we might get a couple characters. Not too impressive as far as what it can do. But what if we up the number of monkeys typing and up some of these other numbers here? So let's take the 1 monkey, go 10, 1,000, 1,000,000. How about 1,000,000 monkeys? Anyone who want to make a guess at how many? If a 1,000,000 monkeys typing, let's make it 1,000 characters per second. How many characters do you think it'll be able to type out? Anybody want to make a guess? It's not very many. I'll start it out here. Begin. Tomorrow. That's what you get. With 1,000,000 monkeys typing 1,000 keys per second, well, we were doing, on our thing there, we'll go up one more, 1,000,000 keys per second. Now we're doing more than we were doing before. We get tomorrow, we get another little O and a W. You see how paltry that is? Now the real thing to look at is that once you get that first little part there, it stops effectively. It's going to take 30 times as long still to get that next letter. Even though you've got 1,000,000 monkeys typing 1,000,000 keys per second, it's still going to take 30 times as long to get that next one, and 1,000 times beyond that. But still, let's increase the time. Instead of being real time, let's go to. Since we're getting near the amount of time here, I'll go up quite a bit here. We'll go up to there's a year, 10 years, 1,000 years. Every tick is 1,000 years, 2,000 years, 3,000 years, and we got 1,000,000 monkeys typing at that rate, 1,000,000 keys per second, and each tick is 1,000 years. How far do you think it'll get? Tomorrow and tomorrow. That's it. Tomorrow and tomorrow. That's as much as you get. All that. So you see what I'm saying? The chances are very deceiving, and the reason why they're deceiving, even to us, is because we have been told over and over and over again that these very unlikely things can happen by chance, and they can't. They just plain can't happen. It would be ridiculous for you. For instance, if I were to tell you that the chances are 1 in 10 million that you're going to, or 1 in 100 trillion, that you're going to walk out this door and you're going to get hit by a meteor. It's just going to come and land. It could happen, right? Meteors do land. It could be when meteor will land on you, but it would be ridiculous for you to, oh man, I got to get out an umbrella or something, a stone umbrella to protect me from that meteor that might come in. No, you wouldn't worry about it because the chances are 1 in a trillion. This is what the chances are that life could happen spontaneously. And the answer is it can't. Right. It just plain can't. Okay, let me take it up all the way to the top so you get really, okay, now a million, we can go a billion, a trillion, quadrillion, what comes after that? Quintillion, sextillion, septillion, octillion, nonillion, decillion. You can see these numbers are going up. Actually, decillion, they add another 3 in there, so it's actually 10 to the 30th. Excuse me. We'll keep on going. Undecillion, duodecillion, tridecillion, quadridecillion, quintessillion, sextillion, septendecillion, octobendecillion, novendecillion, vigintillion. 1 vigintillion. That's unbelievable. That's 10 to the 63rd power. That's that one with 63 zeros after it. What do you think we could produce? Well, we'll keep on going. And plus, let's keep the 1 million going up to a billion, to a trillion. That's as high as I made it to go. A trillion keys per second, and we'll do it where each second that passes represents not a million years, not a billion years, a trillion years. Okay? Remembering that the secular age for our universe is about 13 billion years, not trillion. So this is like every second that goes by is like 30 or 40 times longer than the age of the universe as commonly accepted. Oh, sorry. Let's keep on going on the vigintillion. We keep on going now. We skip over 10 to the 70th, 10 to the 80th, 10 to the 90th, and what comes after that? 10 to the 100th, which is called a Google. I don't know if you knew that. It's spelled different than the Google search engine, but that's what a Google is. Some guy back in the 1900s, early 1900s, made that name up. A Google is the biggest number you could possibly think of anybody ever needing to know. Because, well, if I go back here and you see, if I go back to the 10 to the 90th and then 10 to the 80th, that's the number of particles in the universe. The particles in the universe, not sand on the seashore, not atoms in the earth, the particles in every piece of material in the entire universe is 10 to the 80th. And now a Google is 10 to the 20th larger than that, which is what would that be? That'd be about 100 billion billion, I think it'd be. 100 billion billion. So we're going to go up to a Google monkeys, and we're going to let those Google monkeys go for a trillion keys per second. And each second is a trillion years. Notice what will happen here. You type out a fair amount. Tomorrow and tomorrow and tomorrow. Creeps in this petty pace from day to day to the. And that's it. Now, the thing to notice is that we are now counting in trillions of years. There's 10 trillion, 11 trillion, 12 trillion, 13 trillion. And we're not counting in seconds anymore. A trillion years goes by every second, and we're not adding to any substantial amount. Once again, it'll take 30 times as long to get to the next character, and then 1,000 times as long to add 2 characters. Do you see what's happening here? This is real math. This is what you ought to be learning in your math class and your science class, is that it just will not happen by chance. Okay? And one thing I didn't tell you too, but I want to get back to the card deck here, is that this card deck, I was telling you that not all the card combinations have been found or ever will be found. It's even worse than that. If I put these cards in a random order, which I just did, okay, this has never existed before. It doesn't match any combination that anyone has ever made before. And if I do this, that is a new combination. It's every time you play solitaire on your computer and you give a good random number generator, every time is a different deck of cards. A different permutation of the cards. That's amazing to me. That is something else. But anyhow, so I hope that really drives it home that life happening by chance is a closed book. It's just not going to happen. And we have the answer in Genesis. We have the answer.